So welcome everyone to this webinar. I hope you're excited. This is the first webinar on quant. So I'll start off by talking about why did we choose this webinar? What's the reason behind choosing this particular topic? So as Piyush mentioned that while deciding the topics, we wanted to make sure that we cover almost all important topics. And when we looked at number properties as a module, what we realized was that there are a lot of topics which are using the application of factors and multiple. For example, if you look at prime numbers, when you're studying prime numbers, you must have noticed that while solving questions on prime numbers, you deal with total factors, even factors, odd factors, and those kind of things, right? When you look at topics like LCM GCD, which a lot of people dread, even though they know how to find the LCM and GCD, but when it comes to difficult questions or 700 plus level questions where they need to actually figure out the various possibilities of the lowest common multiple or greatest common divisor, a lot of people falter at this place. And similarly, the application of multiples and factors are also seen in divisibility. So we have seen that there are a lot of official questions where they might just give you statements like these, like m is a factor of 25, or m is a multiple of 25, something like this, and they might ask you to find out, hey, tell me whether is m divisible by such and such number, those kind of statements. And the biggest challenge what I saw was that students falter because sometimes they don't know how to translate the question in the form of an equation, and sometimes there are certain common confusions regarding what basically entails when it comes to factors and multiples, especially when it's related to divisibility also. Okay, so that's why we decided to take up this topic. And as you can see in our properties, primes, LCM, GCD, divisibility, they cover about I would say 50% of number properties, right? Apart from and statistics and even odd and units digit, these are the three major chunk. I would say that, put it that way. So if you understand the basics of multiples and divisors, then you will be able to do well in all three topics. So first of all, what we are going to do is in this session, what I'm going to do is I'm going to first of all talk a bit about the important definitions of primes, factors, multiples, divisors. What are they? But I'm going to discuss it at a very high level. I'll try my best to make sure that it's clear for all of you. But it would be great that from today's session, after whatever session that you attend, if you can go through the basics before attending the sessions, so that you are able to understand all of these properly. I will be covering, again, let me make it very clear, I will be discussing the basics of all these things at a high level. But you can understand we have limited time, 1.5 hour, 2 hour. So it won't be possible to cover the theory or the concepts of all three topics in depth. So I'll teach you a few things concept-wise, and a few things while we are discussing certain questions. So I'll start off with the basic definitions of certain things. Then what I'm going to do is I'm going to start giving you questions on factors and multiples, just so that you get comfortable with the concept of these. Then I'm going to move on and give you questions on primes, basically, where you deal with total factors. So I'm going to discuss questions where there are certain direct application of the question, which most of you are able to do. And there are certain questions where there's indirect application, where you actually need to infer to get the answer. And where I feel students are still not very comfortable, and that's my opinion at least. And finally, we'll end up with certain questions on LCM GCD. So this is the flow that we are going to follow for this session. I have a question here. Can we get the recording of today's session? Yes, we will be sharing the recording of this session with everyone. So no need to worry about it. So guys, if this is clear, let's get started by discussing some basic definitions. Now, first of all, let me ask you, since we are discussing factors and multiples, what according to you is a factor? If I tell you a random statement, if I give you A is a factor of B, let's say, okay, you see the statement written in a question. What comes to your mind when you see this line, A is a factor of B? Can you type it? Can you let me know your thoughts? When you read a statement like A is a factor of B, what clicks in your mind very quickly? Okay, Rohit says B can be divided by A. Okay. Anyone else? B is divisible by A, B contains A. A is completely divisible, leaving no remainder. A is divisible by B. A is a factor of B. Okay, so I told you A is a factor of B is what I told you, right? So when I say A is a factor of B, okay, that's clear. Let's say if I tell you A is a multiple of B, what does that? I'll talk about whether you are correct or incorrect, don't worry. I just want to know your opinion. One last question. When you read the word A is a multiple of B, what is the meaning of that? A is a multiple of B. So most of you have given your opinion about what does A is a factor of B means. What do you understand when I say A is a multiple of B? B divides A completely. Okay. A is equal to BK. Neera says A is equal to BK. Rudar says B completely. Okay, so what I can see is that most of you are correct, but I can see a few of you who are just saying the opposite when it comes to multiples and the opposite when it comes to factors. Okay, one last question before I start discussing the definitions. What is so special about prime numbers? When it comes to factors, what's so special about prime numbers? When you're talking about factors, what is so special about prime numbers? Anyone? What is so special about prime numbers when it comes to factors? Or is there nothing special about it? Okay, Prashant says two factors. Okay, this is good. So I can see one constant answer. Everybody is saying the correct answer. That's correct. It has two divisors, two factors. One is one, the other is itself. So guys, that's very important. The first thing, obviously, the basic thing is, I asked in a different order, is that you should know that a prime number basically has two factors. Now, an important thing that you need to keep in mind, make a note of it if you don't know, is that sometimes instead of the word factors, they might also use the word divisors. Okay, so factors and divisors, they both mean the same thing. Okay, now since I'm talking about factors, let's understand what is a factor. Okay, so when I say X is a factor of Y or A is a factor of B, okay, what basically I mean to say is that if X is a factor of Y, then Y is completely divisible by X, or Y by X is an integer. Okay, so this is something that you should be able to understand very clearly. What you can do is, if you get confused, you're not sure how to write the equation, then you can keep a certain example in your mind that might help you understand. So you can think in this way. You can say 2 is a factor of 6, something like this, which might help you remember. Okay, if 2 is a factor by 6, then 6 by 2 is an integer, something like this, so that in the exam, if you need to create an equation, you are able to do it very quickly, either in this way or in this way. You should be able to do it. Okay, so factors are numbers which will completely divide the original number. That's how I easily remember it. Now, when it comes to multiples, most of you are correct. When I say that X is a multiple of Y, it's a multiple of something, then that means X is equal to KY. Okay. So for example, you can say, if I tell you 12 is a multiple of 6, right? So I can write 12 as 2 times 6. Just one example, random example here, just to tell you that you should be able to, when you read that X is a multiple of Y, you should be able to write X is equal to KY. This equation, you should be able to definitely write it then and there. Okay, is this part clear, everyone? Let me just bring up a poll very quickly. Kindly mark yes if this part is clear. So the main thing which I want to put across here is that you should be able to frame this equation when you see it. I obviously should know the definition, but if you forget the definition, what you can do is you can remember some basic examples in place so that you know how to write it down if you get confused when you're dealing with variables. Okay, so I can see it's clear with everyone, so that's good. So let's move on to the next thing that you should know. That is the total factors formula. Now, whenever you're given a number and say you're asked to find out the total factors of a number, what you basically do is the first step that you need to do is prime factorize the number. Okay, what I mean by that is you need to break down that number in terms of its prime factors to the power something. So if n can be written as p1 to the power a, p2 to the power b, p3 to the power c, and this is very important, guys, that p1, p2, p3 should be primes. GMAT might give you something like this, and say for example 2 to the power 3, 9 to the power 2, and in a hurry, some of you might make a mistake and find out the total factors of this thing exactly, which would be wrong. What you need to do is, first of all, break down this whole stuff into prime number form, something like this. Okay, just break it down fully. So you have a prime number and you have its power, corresponding power. Once you have that power with you, if you want to find out the total number of factors, so when I say total number of factors, what I mean by that is all the numbers that divide n, then what you need to do is you just take this power of the prime numbers, as you can see here, a, b, c, and to find the total factor, you simply add 1 to the power and you multiply it to get the answer. So you can say the total factors of this particular number is 20. Don't don't make this mistake of taking these two power, because this is still not a prime number. So that's a very important thing. I cannot emphasize much on it, that don't make this mistake in the exam. When you're solving the question, make sure that the number is properly prime factorized. Okay. Once it's prime factorized, then only you add the power plus add 1 to the power and then multiply it. Okay. I hope this is perfectly clear. Um, and here are a few examples that I have just to make this very clear. If I want to, for example, find out the total positive factors of say 120. Okay, so what I basically do is I first of all break this down. And this is one way of breaking it down. So you write it as 12 times 10, then you break 12 again into 2 square times 3, you break 10 as 2 times 5, and you club them up. Now, once you have this with you, you can find out the total factors by just taking the powers of these numbers, add 1 to it, and then multiply it to get the answer. Again, this is just the very basic. Obviously, there are higher applications of it, which I'm going to definitely discuss. But is the formula clear? Do you understand how to find out the total factor of the number? If this is perfectly clear, please mark yes, so that I can talk about just one last thing before we start solving questions. If this is clear, please mark yes. Okay, great. So I can see all of you saying yes, which is good. So let's discuss the second part, the last part basically of the theory is how to find out the lowest common multiple and the greatest common divisor. Okay. Now, keep in mind, prime factorization is a very important part of prime numbers, LCM, GCD. What we did here, basically, this part, this activity of breaking it down into this form is known as prime factorization. Okay, and so even when we are solving questions of LCM, GCD, what we need to do is, if you're given a number, say for example like this, if you want to find out the LCM of say 24, 36, and 80, three numbers are given. They're telling you find out the smallest. When I say lowest, means lowest multiple. Now, what did we learn? What is a multiple? So if I want to find out the multiple in this case, what I'm going to do is I'm going to first of all prime factorize these numbers. So I'm going to write 24 as 2 cubes times 3, 36 as 2 square, 3 square, and 80 as 2 to the power 4 times 5. Now here's an important step that you need to keep in mind to find out the LCM. And this is slightly different from GCD, so be careful here. Now, the first step that you need, after doing this, in the second step, what you do is you take all the unique prime numbers in it, okay? All the unique prime factors. So you can see these three numbers, basically, they have the prime factors 2, 3, and 5, as you can see here, right? So what you do is you take up all these three prime factors and you take their respective highest powers. Okay, so in this case, I would pick 2, 3, and 5 because 2, 3, and 5, they're all present in it. And once I take these three, I look at what is the highest power of each prime factor. So in this case, if you look at all the 2's, you'll notice the highest power is 4. So you'll take this as 4. The highest power of 3 in this case is 2. So you'll take 2. There's only 1, 5. The power here is 1. So you have to take it as 1. And this will tell you the lowest common multiple of all these three numbers. Is this part clear? Now, the only difference between LCM and GCD is that in GCD also you prime factorize. There's nothing different there. So the first step, if I'm trying to find out the GCD, is going to remain the same. Nothing changes. But in step 2, what you need to do is you need to take only those prime numbers or prime factors which are present in all three numbers. Okay, in this case, see, 3 wasn't present in all three of them, but I still took it. So in this LCM case, I'm taking all the I'm taking all the numbers here. Okay, I hope this part is clear. Then I'm taking all of them. But in this case, I'll just take the one that is present in all of. So the 2 is the only thing that is present in all of them. Okay, so I'll take that prime factor, and I'm going to take the lowest power in this case. So I'm going to take 2 square. The GCD in this case would be 4. If you have any doubts, ask. Let me just bring up the poll very quickly. If this is perfectly clear, guys, kindly mark yes so that we can start solving questions. So this is again a high-level understanding of both of them. Obviously, while discussing questions, you'll see more advanced application of these. So I have a few easy questions, a few difficult ones, and okay, I can see a few no. So guys, those of you for it's not clear, please ask questions if you can. I'll try to answer them to the best of my abilities. I can say about 8%, 7% of you saying you don't understand this. So please let me know what is not clear. Understand what is a divisor. A divisor is a number which should divide. If I'm looking for the GCD, I'm looking for a number which divides all these three. I'm looking for a number that should divide all these three numbers. So basically, I have to find out a common number which is present in all of them, a common entity. Now, what is common in all three of them? The only thing that is common is 2 square. That's the minimum that is present. I cannot say, for example, take 2 to the power 4. If you're wondering why did I not take 2 to the power 4? Now go back to the definition. What's a divisor? A divisor is a number which will divide the original number completely, right? Divisor or factor, whatever you want to call it. Now let's say I take the highest power 2 to the power 4. 2 to the power 4 will divide this number, but it's not going to divide 36 and 24. That is why we need to take the common part that is present in all of them. So this is a common question, so I hope this is perfectly clear. Okay, so guys, I'm going to start off with the first question. And the process is going to remain the same. Those of you who have attended the session before, I'll give you the question. I'll give you about 2.5 minutes to solve it. And I will request all of you to put your answers in the poll and not in the chat, okay? Once you're done solving, I will start the discussion. I'll tell you how you did, what is the best way to solve the question, what's the best approach to go about it. Okay, so let me start by giving you the first question, guys. Here's the first question on your screen. And I am going to bring up the poll for this one very quickly. So I've added the poll. You have the question. Get started, guys. All the best. You have 2 minutes to solve this. Another 15 seconds, guys. Then I am going to end the poll. So those of you who haven't responded, I would highly encourage you to do so. It's perfectly okay if you don't know the answer. In GMAT, as I told you, you will have to mark something. So Take your best shot. Whatever you think could be the answer. Okay, and so I'm going to end the poll now. Okay. Okay, so frankly speaking, most of you got it correct, as you can see in the poll. About 88% of you think the answer should be B, and I have a few E's, D, A. Thankfully, nobody marked C, which is good. Now, tell me, those of you who could solve the question and those of you who marked other answers also, what was your thought process? What was going on your mind when you were solving this question? How did you go about when you read the question which says the integer n is a divisor of 72 as well as 90? So what does that mean? What are they talking about? Okay, Atul has given me an answer. Let me just make the chat public. Okay, Sugandha says I eliminated options, but it was risky, Sugandha, because there's an option E. You might have fallen for, but there could be multiple cases. But okay, fine. First time factorize and then find the GCD. That's good, guys. So see, that's pretty good. This is again a 600 level question, and I can see that all of you got it correct. So whenever you see that a particular number is a divisor of two numbers, what you need to understand is that 72 is dividing n is divisible by n. 90 is divisible by n. So I'm looking for a divisor, a factor which divides both of them. So the first step that you can do is prime factorize and find the common divisor that is present in both of them. And the first thing that you should do is find out the greatest common divisor, because you're looking for a divisor which divides both of them. So you need to look for a common one. Now, 72 is what? It's basically 8 times 9. So I'll say 2 cubed times 3 square. 90 is 2 to the power 1, 3 square, and 5 to the power 1. Okay. Now I'm looking for a common divisor. So the greatest common divisor in this case is going to be, obviously, as I told you, in greatest common divisor, we first of all see what is common. We can see this is fully common. They both have 3 squares. So you take that, that's easy. But even 2 is common. So I'll take 2, but I did tell you in greatest common divisor, I take the smallest power, because that's the maximum common that I can take out of it. So I would say 2 to the power 1. So in this case, I would get my answer as 18. 18 lies between 9 and 30. So I'll say the correct answer in this case is going to be 18. Okay, Ashima is asking why not LCM? Okay, again, you need to understand the definition. What is LCM? LCM, when you say LCM, that is, you're looking for a multiple. So 72, think about it in this way. If I find out the LCM of 72 and 90, let's think about it. That's okay if you're asking this question, that's not a problem. When you find out the LCM, you would get what? Let's write it down very quickly. Okay, you would get 2 cube, 3 square, and 5 to the power 1. Okay, you are saying that this is n. Now, after finding this, let's say this is for a moment correct for a moment. Think about it. I'm looking for n, which is a divisor. Basically, n should divide 72 and 90, right? It should completely divide it. Now, think about it. Will 2 cube times 3 square times 5 to the power 1, if I put it in the denominator here, will this divide 72? I hope this part is clear. Ashima, I hope this is clear why we are not taking the LCM, because we are looking for a divisor. An easy way to understand is in this way, and that would be much more easy for you. If I take a number n, let's take a number, say 6, for example. When I say find out the divisors of 6, I'm looking at numbers which are 6 and smaller than that, which can divide it. So 6, you would take 3, you would take 2, you would take 1. Okay, so divisors are basically which are equal to that number or less than that. Okay, when I say multiple would be greater than those numbers, like 12, 18, 24, so on and so forth. So if I'm looking for a divisor of this, I'm looking for a number which is smaller than this or equal to this. Okay, Joe is saying, why does the question place the range limit? It's a question, Joe. I can put anything that I want in it, right? So that's just a limitation. And by the way, the limitation in this case is just to distract you, frankly speaking. But there's a learning which I wanted to give it to you. So I'll talk about that. Joe, that's right. The answer won't change. But there's a purpose of giving you this question. I'll tell you what that purpose is. Just give me one sec. Let me use the eraser very quickly. Okay. Now see, in certain questions, in questions like these, okay, they might also ask you this question. They might ask you, instead of giving this limitation, they might ask you how many values of n are possible. What would you do then? Ashima, that's a good question. When we will decide when to take GCD and when to take LCM? One common way, one easy way is to look at the keywords that are given in the question. They are a clear-cut indicator of what you need to do. Like in this case, the word divisor is like a trigger, which is telling me, hey, I'm looking for a divisor of a number. So I need to think in terms of factors. So I need to think in terms of GCD. If you see the word multiple written somewhere, okay, then that would be a trigger that you need to think in terms of multiples. You need to think in terms of LCM. Okay. Okay, guys, can you answer my question? How many values of n are possible? Anybody? Okay, Arun says 6. Neera says then n will be 5. 5 possible values. Okay. Anyone else? Again, guys, discard these options. Okay, don't think in terms of these options. Frankly speaking, don't think. This is a brand new question. How many values of n are possible if I ask you? There is no limitation. I have removed the limitation. This is not there anymore. The rest of the question remains the same. Integer n is a divisor of 72 and 90. Okay. And I'm asking how many values of n are possible. Okay, Rudar says 6. Shushri says combination of all prime factors which give us all values of n. Joe says 4. Okay. This is a very important question, guys. This is where it becomes the 600 question levels automatically becomes a 650. Understand this. What is GCD giving you? GCD is giving you the biggest, the greatest number that is possible, which will divide the number 72 and 90. Okay, that's the biggest number. So 2 to the power 1 times 3 square. Now, there could be other divisors also. Okay, when I say other divisors, what do I mean by that? The other divisors, what I mean by that is it's quite possible that if 72 and 90 is divisible by 18, then obviously it will be divisible by 2 also. It will divisible by 9 also. It will be divisible by 3 also, right? So what I mean to say here is that if you want to find out all the values of n that are possible, find out the GCD. Once you found out the GCD, all factors of this, all factors, let me write it down, all factors of 18 will definitely divide 72 and 90. Is this part clear? That's the main inference that you need to keep in mind. Now 18, what are the factors of 18? How do you find out the factors of 18? I just told you how to find out the total number of factors by using the formula of factors, which is you look at the power, you add 1 to it. So 1 plus 1 times 2 plus 1. And you would say there are 6 factors of 18. Since there are 6 factors of 18, 72 and 90 will be divisible by 6 different values of n. And if you want, I can write it down for you so that if anybody is wondering, how am I getting this answer? These are the 6 factors. 1, 2, 3, 6, 9, and 18. Okay, so what's the learning? What's the takeaway from this question? Number one, if you see that it said that n is a divisor, so basically I'm looking for a number which divides both of them. So I'm looking for a factor. So the first thing that you need to do is find out the GCD. That will give you the biggest number. Now, if they tell you find out all the possible values of n that will divide it, after finding the GCD, just find out all the factors of 18. Because if 18 divides the number 72 and 90, all factors, smaller numbers of 18 will definitely divide 72 and 90. I hope this is perfectly clear, guys. If you have any questions, please feel free to ask in the chat pod. I'll try to help you to the best of my abilities. But this is the idea behind this question. So those of you who are confused about when to use GCD LCM, you look for trigger words. That's sometimes helpful. But if you're wondering how to find how many possible values of n, the process is simple. Find the greatest value and then find out all the factors using the total factors formula. That's it. Okay, I don't see any questions in the chat pod, so I'm assuming that this is perfectly clear. So let's go to the second question, guys. So here's the second one, and let me bring up the poll quickly. And here's the poll, guys. Again, you have 2 minutes to solve this question. If anyone has any doubts in the previous question, please feel free to ping me on the chat. Another 30 seconds, guys, then I'm going to end the poll. So there are certain doubts which I want to clear upfront only. I think some of you may have joined late, so you might not be aware of it. The total factors, there's a formula for total factors, okay, which I talked about. You need to prime factorize the number, break it down into form of prime numbers. And once you have that prime number in the powers, then you add 1 to all the powers and multiply it to get the total factors. Okay. And the total factor formula can be applied for any numbers. If I want to find the total factor of 6, I can do that. If I want to find the total factor of 500, I can do that. It can be used for any number that I want to. Okay. Okay, guys, I'm ending the poll now. So those of you who haven't marked, do so very quickly. If you're still struggling, just take a guess what you think could be it so far, whatever you have learned. Okay, I'm ending the poll. Well, this is the kind of response that I had expected. If you look at such questions on GMAT Club or any forum of GMAT, you'd see that people are usually split between 2 options. One of the options is a trap. I'm not going to tell which one it is. Is it a trap or a D trap? But there's a trap set in such kind of questions. But then somebody now asked me how to figure out when to use LCM, when to use GCD. Now, after solving this question, after reading this question, could you understand what you need to use? Anyone? Were you able to understand what do you need to use in this? Do you need to use the concept of GCD, or do you need to use the concept of LCM in this question? What do you need to use? Anyone? What do you need to use in this case? Do we need to use the concept of GCD or LCM? Okay, you can see the keyword multiple written here. Okay, the moment you see the word multiple mentioned, that should be a trigger that you are thinking in terms of LCM only. Okay, having said that, that doesn't mean that LCM would be the answer. LCM can help you get the answers, how I'll put it. So how do you, so what I do is whenever I read a question like this, and I see it's an integer. Ideally, I would have mentioned if n is a positive integer. Let's do that. In GMAT, it would be written like this only. If n is a positive integer, is n a multiple of 80? Okay, and just one sec, guys. Let me use a different color. Just one sec. Yeah, I think this is fine. I need to find out is n a multiple of 80? Okay. Now, when I see this, what I do basically is I write down the equation which I was talking about. N is the multiple of 80. So N should be N written like this basically. 80 times K, where K can be 1, 2, 3, 4, whatever that needs to be. So N can be 80, N can be 160, N can be 240, anything. But this is what I'm kind of looking for. Okay. Note here, you're not asked the exact value of N. A lot of people, what they do is they end up trying to figure out, can I get the actual value of N? That's not required. You just need to prove this somehow. Okay. So once you've made that inference in step 1, what you should do is you should go to step 2 and look at the first statement. The first statement is N is a multiple of 5 and N is a multiple of 16. So N is a multiple of both 5 and 16. Okay. Now, if I ask you, can anyone tell me what is the smallest value of N such that it is a multiple of both the numbers? It's a multiple of both the numbers. How do I find that? I'm looking for the smallest possible value. What concept am I going to use? I'm going to use the concept of LCM, right? As all of you mentioned. So I'm looking for a multiple. If I want to find out the smallest multiple, I can say the smallest multiple of 5 and 16. Again, see, I'm prime factorizing it. I'm writing 5 as 5 to the power 1, 16 as 2 to the power 4. And I can say the smallest value in this case is going to be, I don't know why my pen is acting up today. The smallest value that it's going to take is going to be 5 to the power 1 times 2 to the power 4. Okay. And this is basically 80. Now, this does not mean that N is 80, guys. Please understand this. This is the smallest possible value that is there. Now, using this statement, I can say that N, it could be 80 times K. It could be anything. I don't know what it is, but I know it is definitely 80 times something. Only then will it be a multiple of 5 and 16 both. Notice if I break it down, if it's confusing somebody, this is how you need to think about it. It's a multiple of 5 and it's a multiple of 16. It could have anything else also. I don't know. N could be 240 also. That's not a problem for me. Okay. It could be 240, but 240 is when K is 3. N could be 160. That's not a problem. But I know for sure that N contains 80, because if it does not contain 80, it will not be a multiple of both of them. So this is telling me that N is 80 times K. That is why this statement is going to be sufficient. So this statement is sufficient. Now, if this statement is sufficient, my answer is going to be either A or D. So I'm canceling out other options. Okay. Now, here is where it gets tricky in statement 2. Now, people who are not thinking in terms of multiple, what they do is when they see N is a multiple of 8 and 10, they blindly say that N is a multiple of 80. If you do this, you're making a mistake. You're falling for a trap here. You're looking for a multiple which is of both of them. So again, you're looking for the LCM. But what is the process that I've told you to use? The process that I've told you that you need to use is by writing it like this. Just one sec. You prime factorize. You write it as 2 cube, 2 to the power 1, 5 to the power 1. Okay. Now the LCM of this is going to be 2 cube. I'm taking the highest power times 5 to the power 1. Now notice this is 40, not 80. So after using this analysis, all you can say is that N is a multiple of 40. You can be sure that it is a multiple of 40, but you cannot be sure whether it's a multiple of 80 or not. I hope this part is clear, guys. This is where people fall for a trap. It's a typical GMAT question that you would see in the exam, statements like these. So when you see multiple, don't just multiply them. That's a major takeaway from this question. Don't just blindly multiply saying 8 times 10, 5 times 16. Find out the lowest common multiple first. Lowest common multiple is prime factorization, taking the highest power of the prime numbers. Okay. I hope this is clear. I'm going to talk about the question level, guys. Don't worry about it. But first of all, please tell me whether it's clear or not. Okay. I'll talk about the question level. But is the process clear? Say yes, no. Let me just bring up a poll very quickly. Yes, no poll. So I hope this is clear. So second statement is not sufficient because I cannot tell definitely it is a multiple of 80 or not. So the answer in this case is going to be option A. So I hope this process is clear. Try to take up those questions which are quite common on the GMAT. This is a 650 level question. Okay, but frankly, if you know the process properly, you will be able to solve this question very quickly. You can see it would hardly take you a minute and a half if you know what you're exactly looking to find out. Okay, I can see still 3% of you saying that you have not understood it. I would request you guys, please ask questions, send me a private chat, ask questions where you're faltering, and I'll try to help you out. If your concepts are not clear, for example, if you don't know anything about prime factorization, then you might face some issues, frankly speaking, because there are some applications of prime factorization here. Okay, but at a high level, what I want to say is if you have multiples, look for lowest count multiple and then move from there. Okay. Now here's your third question, guys. If you've understood the concept of factors, so far we have been dealing with a lot of numbers. Now you might get questions on the GMAT which might deal with just variables. Okay. So try this one out and let me bring up the poll for you. Okay, I can see 5% of you did not understand this. Please, guys, ask questions on the chat. I'm bringing up the poll. Just one sec. Okay, guys, I've added the poll. You're free to solve the question now, and you have 2.5 minutes. Another 30 seconds, guys, then I'm going to end the poll. So those of you who haven't responded, please do so. Okay, I'm going to end the poll in 10 seconds. Very quickly put in your responses. Okay. So I have a split. Frankly, I expected more D's, but this is good. I can see that 43% of you think that the answer should be A. And I have an equal split between D and E. This question, by the way, is a 700 level question, only because of the fact that we are dealing with variables here. So most people are not comfortable with it, and they end up making a mistake in this. But frankly speaking, if your concept is clear, this question would take you about 1.5 minutes to solve. And I'm going to tell you why. Okay, but before that, let me ask you a few questions. How many of you took values to solve this question? Kindly mark yes if you took values to solve the question. How many of you took values to solve the question? I've added a poll. If mark yes if you used values to solve the question. Wow, I have almost an even split. Okay. Okay, I'm ending the poll. So I can see about 47% of you did not use it. Just a second ago, it was almost 50-50. So I had an inkling that you might use values to solve the question. That's why I asked it. Can you tell me, and this is a question which I asked in the starting also, if I see something like this, that let me go back to the present. If I see something like this, is A a factor of B? Okay, is a factor of B. When I see a statement, if I want to write an equation, just an equation to express this, right? How should I do it? Like in the previous question, we wrote it as n is equal to 80k, right? Now in this case, if I want to just express it as some expression, what should I write it as? Can anyone tell me? Is a factor of B? I told you factor is a number which divides it, right? Very good, Likit. That's correct. B by A, very correct. B is equal to 8. That's absolutely correct, guys. That's very good. So basically, when I say is a factor, that means A will completely divide B. So I should get an integer. Let me call it as K. So what I mean is B should be, is B K times, let me write it like this. I don't know why my pen is acting very strange today. Really sorry for this. So basically what I want is B is A times K. This is what I'm looking for. Is B equal to A times some integer? The moment I get this, I will be able to get I can say that particular statement is sufficient. But the idea is to write it exactly like this. Why? Because when you're working with these statements, what you're going to do is you're going to keep B on one side and take the rest of it to the other side. Okay, and then do whatever you need to do. And one more small thing here, in the statements, I can see the variable K. So what I can do is I am going to take a different variable so that you don't get confused. So let me take it as Q or something like this. Okay, Q, where Q is an integer. Now let's look at the first statement. So we have done our analysis, and this analysis is important. Now first statement is a square plus a minus b is equal to 0. Now I want to keep b on one side and the remaining stuff on the other side. So I'll write it like this. B is equal to a square plus a. And what I'm going to do is I'm going to take a common out of it because I'm interested in a and b. Now notice this statement is exactly how I want it to be. This is, notice this, you have b here, you have a here, and you have some integer here. What that integer is, I don't care. But what I can say is that if b is equal to a times q, that means a is a factor of b. If this seems confusing, you can also write it like this so that it helps you understand. We know is an integer greater than 1. So a plus 1 is an integer. And if b by a is an integer, then that means a is a factor of b. I hope this part is perfectly clear, guys. Okay. Okay, I can see all of you are saying the same thing, which is good. Now let's come to the second statement. Now the second statement is just a slight variation, but where I expected you to do some inference. That's all. Here, same stuff. I'm going to write it as a times a plus 1 divided by k. Okay. Now, once again, if you want, you can write it like this. You're looking for b by a. You want to know whether b by is an integer or not if you want to look at like this. Now you have a plus 1 by k. Okay. And there is no information about what is the relation between a and k. I have no clue. Okay, I cannot be sure what's happening here, whether it's an integer or not. I'm not sure about it, whether a plus 1 by k would give me an integer or not. That is why I cannot say with surety that a is definitely a factor of b in this case. Is this part clear, guys? Because this is the only tricky part in this question. If you get this part clear, after this, I'm sure you must have understood what the answer is. So if anyone has any doubts, please ask. What you need to do is you need to think in this way, that you don't know what's the relation between a plus 1 and k. If you had known the relation, you could have got the answer. For example, if Just giving a random example. If this turns out to be 6 by 3, a plus 1 by k, not a problem. You'll get an integer. But this could be also 6 by 5. A plus 1 could be 6, k could be 5. I don't know what these values are actually. Okay. And again, these are random examples just to help you out. But the idea is, since you don't know the relation between these two, you cannot be sure whether this is an integer or not. If you're not sure about it, you cannot comment. So this is not sufficient. This is sufficient. So the answer in this case is going to be option A. So see, what the main point that I want to put across here is that if you want to take numbers, go ahead, do it. But if you understand the concept, if you know how to write when you see words like factor and multiple, all you need to do is hone your inference skill. You just need to be able to infer properly and come with the answer. Now tell me, how much time would it take to simplify this and this? 30 seconds at the max, and another 30 to 45 seconds maybe to infer what you want, what you're looking for. Okay, I can again see most. Do we need to assume the value? No, Ashim, I would strongly suggest not to do it. The reason I asked you this question was because a lot of people assume and then start solving questions. Okay, that's why I don't prefer using it. You're not sure what numbers should you use. That's another question that is there. What numbers should you use to solve this question? So it's better to write it in the form that I'm talking about. This is something that you need to know. If you don't know it, you will not be able to solve the question properly. So if you know this, any question which deals with variables or non-variables, you will always get the question correct. Okay, Mohit is asking what was the answer of the previous question. Are you talking about question number 2? If that is the case, the answer was A. In this case also the answer was A, guys. Okay, Shiv is asking, so it's the unknown variable k that makes it insufficient. Otherwise, yeah, A plus 1 is fine. K is also fine. See, both of them are integers, that's fine, okay? But we don't know whether A plus 1 by K is an integer or not, okay? Now, Arun has a question. We know B by A is an integer, K is also an integer. So, integer times integer is integer, which means A. Yeah, Arun, see, understand this. A plus 1 is an integer. There's no problem with it. K is also an integer. There's no problem with it. But I don't know whether A plus 1 by K will divide perfectly or not. I hope you get that point. Now, A and B could be integer, right? I could say A is, just giving a random, A is 5, B is, say, 4. They are integers, but it's not necessary that B by A would also be an integer, right? In this case, at least. I don't know, right? But if this turns out to be 2, like A turns out to be 2, for example, then in this case, B by A would be an integer. So I don't know what's actually happening here because they're dependent on this. They are integers, A plus 1 and K, but I don't know whether they'll cancel or not. Okay, Arun, I hope this answers your query. I hope, Shiv, it's clear that it's a known variable k that makes it insufficient because we don't know what's the relation between k and a plus 1. Okay. Any other questions? Okay, I don't see any other questions here. So guys, I'm moving on to the next one. Okay, here is it. And let me bring up the poll. Okay, guys, I published the poll. You have 2.5 minutes to solve this question. Karan, I can understand that it happens that you know the concept, but you miss on the application. That's the purpose of this question, so that you get this perfectly clear how you need to use this. Parth, I told you that this question was, the previous question was a 700 level question. Okay. If everything is clear so far, ideally most of you should be able to solve question 4 correctly. I expect about 70 to 80% of you should get this answer correct. Another 30 seconds, guys. I can see a few responses. It would be great if all of you can start putting in your responses. You have 30 seconds. Once again, if you understood the previous one, you should be able to get this correct, but no pressure, okay? Even if you get it incorrect, I will be more than happy to help you out. 10 seconds, guys. Everyone, very quickly, put in your response. Okay, I'm ending the poll now. Okay, I had expected about 80% of you to get the correct. In fact, at a certain point of time, while you were solving this question, I had about 100% correct answers. It was only when I said 10 seconds, I think people started marking guessing, which is okay. But, and I would want to break down this question, especially for those who could not do it. I would like to understand where you faltered, why you faltered, okay? So let me ask you a few questions while solving this. First of all, I've been told that the positive integer p is a divisor of q. So this is my process of solving this question is to break things down. Okay, so I look at this and I'll make some inference. Okay, so when I say p is a divisor of q, what does that mean? Can anyone tell me? P is a divisor of q. What is the meaning of that? Divisor. What is divisor? Is divisor a factor or a multiple? What is it? Q by P is some integer. Okay, Q is equal. So see guys, so you understand this, right? So what I mean to say is that Q by P should be some integer because it's a divisor. So I should get some integer. Now you can take that as some variable or whatever, but that is the first inference that you should be able to make, that P is a divisor. So P will divide Q completely. Good. Number two. Now Q is the smallest positive integer. Now whenever I see these words, it's like my mind starts thinking about multiples, factors, those kind of things. Smallest positive integer, which is a multiple of 36 and 100. So Q is the smallest, okay? And also a multiple of 36 and 100. So what am I looking for here in this case? Multiple. So what am I looking for here? Okay, Ashima, you said factor GCD, but where is factor written? Factor is just one place. When I saw the factor here, I wrote it as like this, okay? Now when I see this is the separate part which is talking about Q, what Q is, we should be able to infer that it is the LCM of the two numbers. Very good. So I can see most of you are saying the correct answer, which is absolutely good. So you will say this is the LCM of 36 is 2 square times 3 square. 100 is 2 square times 5 square. So Q is going to be 2 square times 3 square times 5 square. Okay, this would give me Q as 900. So I hope till this part it's perfectly clear. Okay. Okay, Atul is saying Q can be 0, 900. Atul, it's clearly said positive integer. A positive integer starts from 1. It never starts from 0. So if you assumed Q to be 0, you made that mistake. Okay, so please keep in mind positive integers start from 1. Okay. Any other queries till this point? I hope this is perfectly clear. So Q is 900 and P divides Q. That is also something which we know. Now, third part is if P is less than square root of Q. So now there was another information that P is less than square root of Q. So P is less than 30. So I'm looking for a values of P which is less than 30 and it should completely divide this. Completely divide. See, I'm breaking down everything, making sure that I make no mistakes at all. Okay, now last, but the question is which of the following could be true? So they are not looking for a must be true. I just want to figure out a possibility. Is there a possible value, a possibility of the particular statement being true or not? Okay, The first statement is P is a multiple of 10. It's a multiple of 10. Okay. It should be less than 30. The statement is this. And I have two constraints. It should be less than 30. And the third part is it should divide 900. Can you tell me of values which is a multiple of 10 and divides 900 and is less than 30? Anyone? Tell me a value of P, multiple of 10, which satisfies all the condition. It divides Q and it is less than 30. Just one value. Anyone? Okay, Likit, very good, right? So P could be 10, P could be 20. I'm looking for a could be true. So the moment I can just think of one value, I can say P could be 10. I'm looking for a could be true statement. So that is true. Very good, guys. Second one, P is a multiple of 15. What was the role of the first part before and are you talking about this part, Ashima, this part? What is the role of the first part? Is this part? P is a divisor of Q. Are you talking about that? Uh, Guys, absolutely correct. The second statement, if P is a multiple of 15, less than 30, we can choose 15 as the value. Very good. That's also correct. So this is also true because I can take P as 15. Okay. Ashima, this is, see, I'm finding out my answers using this only. P is a divisor. So P should divide Q. I need to be able to divide it. Okay. So when I'm saying P is a multiple of 10, I'll look for a value which will be a multiple of 10 and which will also divide Q. So that is the use of the first part. So that tells me I can take the value of P as 10. If I take P as 10, see 900 by 10, I'm using this one, is an integer. So it's satisfying the first part. I hope this is clear now. Okay. What about the third part, guys? P is a multiple of 24. P is a multiple of 24. Is it possible that P could be a multiple of 24? Can we get a multiple of, can P be 24, say, for example? Is it possible for P to be 24? If yes, why? If no, why? Not possible, right? It is not possible because if I take it as 24, 900 by 24 is not an integer. I'm not getting an integer. So this statement has to be false. Okay, so the only thing that could be true is statement 1 and statement 2, and that is why the answer in this case would be option D. Okay, so guys, I hope this is perfectly clear. This is the way you need to break down stuff to solve the question. Break it down, write down each and every part, and don't forget the role of each and every part. So P divided by Q tells you that I'm looking for a number which divides. Okay. Uh, you find out the smallest integer, multiple word is given, so you find out the LCM, and then you use the constraint to find out the range of P and then start finding your answer. Step by step, if you follow it, you will get your answer. You have sufficient time in the exam, believe me, 2 minutes is more than enough. So those of you got it correct, well and good. Those of you could not vote and still got the correct answer, well and good. I just want you to get these correct. Ideally, 73% is not bad, but ideally I would have expected more than that, at least 85%. So if people are still making mistakes, if there's still any doubt, please feel free to ask in the chat box. Now, here's a 700 level question. So give it your best shot. It's pure play inference based question that is in front of you. You just need to be able to infer properly. Again, you have 2.5 minutes to solve this. 30 seconds, guys. Then I'm going to end the poll. Make sure to infer properly while marking the answer. Okay, I'm going to end the poll now. Okay, I hope you can see the result, guys. A very interesting result, all over the place except for B. A lot of you think that the answer should be B, and I have A and C as the next highest, 18% each, and a few C's and D's also. First of all, let me tell me your thoughts. How did you find this question? Was it too difficult? Was it easy? You found you had difficulty inferring? What happened? Tell me. How did you get biased if when I said it's a 700 level question? Did anything like that happen? Okay, Prashant says is medium. Yogi says difficult. Ashima too difficult. Difficult to infer the statement too. Okay, making inference was a bit difficult. Yes, second statement, frankly, is slightly difficult. I would agree, especially if you just know how to find out the total factors of the number. Then it might be slightly difficult. If you know how to find out total factor, odd factor, even factor, if you know the concept of that, then there's a chance that you might be able to do this quickly. Okay, Joe said easier than the last question, which is good. If you find this easy, very good. Okay, guys, let's discuss this. Once again, I'm going to break down the question step by step, and then let's see if you are on the same page or not. So, as usual, the way I start is I read the stem, I see what they're telling me, and on the basis of that, I solve the question. And once again, guys, there's one small thing which I would have added. If any one of you got biased with this, really sorry. I would have preferred adding the word positive here. If x and y are positive integers in the exam, that would be given. So if any of you missed that, you were thinking about negative integers, apologies for that. It has to be positive. But apart from this, they're integers. Okay. Can anyone tell me what did you infer from this? I need to find out, is 6x plus y an even number? What is, did you do anything with this, or you simply moved on saying, okay, I need to find this? Or did you make any inferences? If you made any inference, can anyone tell me what inference did you make? Did anyone do anything with this? Okay, Mohit says, is y odd or not? Okay. Is y even? 6x. That's very good, guys. That's very good. That's very important. If you're doing this, that's absolutely good. That before jumping to the statements, you should look at 6x plus y. You want to figure out whether this is even or not. You already knew they are integers, so 6x has to be even. You know this also. So you don't need to worry about x. That's the first inference that you should be able to make. That while looking at these statements, x is not what is important. I don't care about x because 6x is always even. So if I want to figure out whether this whole thing is even or not, all I need to figure out is the nature of y, whether this is even or whether this is odd. And notice this is a yes no question. So I'm okay whether I get even or odd as long as I get something. Okay, I don't have to specifically get even only. If I get odd also, that's fine. But I need to figure out what is y, the nature of y. Okay, x is not important. That's the inference that you should make. So I hope this is perfectly clear. Okay, so I can see all of you are saying the same thing, which is good. So let's go to step two, which is looking at the first statement. And here is where things will get interesting. Okay, x times y is a factor of a prime number, factor of prime number. And let me break this down into two parts. What is the use of this information? X times y is a factor of a prime number. What did you do with this? What can I do with this? What prime numbers did you take while solving it? Let me ask you that way also. Because most of you did not say anything about statement 1, so I'm assuming that was easy for you to make inferences. Can anyone tell me what did you do here? Prime factor are 1 in itself, that's good. So 2 is the only even prime. It can be 2 or that's very good, guys. Either x or y equal to 1. That's absolutely good. That's absolutely good, guys. Now, if x into y is a factor of a prime number, and frankly, if I'm looking for even odd, the first prime number that I would think about would be 2. Okay. Now I'm saying x times y is a factor of the prime number, say 2, if I'm taking prime number as 2. So that means one of the factors of 2 is 1. The other factor of 2 is 2 itself. Now, for a moment, let's think in this way. If x times y is equal to 2, okay. Now, there's a possibility that x is 1, y is 2. But there's another possibility that x is 2, y is 1. And that is enough for me to make my inference. I don't need to take any more prime numbers. If you want, you can take it. But the moment you get contradictory answers, that is the moment where you will stop. So I can see there's a one case where y is even. And there's another case where y is odd. And since I'm getting two contradictory answers, that is why I'll say statement 1 is not sufficient. I hope this is perfectly clear, guys. And there's no doubt in this statement. Okay. X into y is a factor of a prime number. I'm looking for even odd. So I took basically y as even, the prime number as even, and I just took one of the cases that say 2 and figure out that y could be anything. Okay. Keep in mind, you could have taken something else also. You could have taken 7 also. That's not a problem. But since you're looking for even odd, you had to take this case. If you would not have taken this case, then you would have always got y as odd. Because if I take this case, I'll always get y as odd. So this case is necessary. And that's a trigger. When you see even odd, when you see prime numbers, that's a trigger that I need to think of even primes and odd primes. If you're not doing this, make a note of it. Okay. Now let's come to the most important second statement where there's a lot of learning. And before discussing this statement, I would like to just do a small exercise to help you so that you understand the statement better. So what I'm going to do is I'm going to take two cases, okay, small ones. Let me take this as 3. Let me take this as 5. Just one. Let's take these are two numbers, for example. Okay. Just to help you understand this. Okay. And let's take the second case first. Let's take Q first. Okay. If I ask you, hey, how many odd integers is Q divisible by? Okay, how many odd integers is Q divisible by? What will be your answer? It's an open poll, so you can answer in the chat box only. I won't be adding any poll as such. It's an open question basically. So say Q is 2 to the power 1 times 3 to the power 1 times 5 to the power 1. If I ask you how many odd integers is Q divisible by, what will be your answer? Okay, Likit says 3, Prashant says 3, Joe says 2, 3, 3, 3, 2. Guys, you're making a mistake. All of you may have made a mistake. Think. You're missing one very important odd number. Akash says 4, Arun says 4. Very good, guys. Very good, guys. Those who say Rudar Daman. That is the answer that I was looking for. 1 plus 1 times 1 plus 1, 4. Very good. See, understand this. When I say how many odd integers is Q divisible by, divisor, that's a trigger that you're looking for factors. Okay, you're looking for odd factors. I hope this part is clear. Now, when you're looking for odd factors of Q, what you need to keep in mind is that now 2 is an odd number, right? You don't need 2 to find out the odd factors. So when you're trying to find out the odd factors, what you can do is you can forget about 2. You're not interested in that because you're looking at odd factors. So even if there is a 2 in it, simply discard it. That's the process. Discard that. You don't care about it. You just look at the odd prime numbers that you have and you find out the total odd factors using the same formula that I gave you for total factors. You can use the same formula. You can say 1 plus 1 times 1 plus 1. So total odd factors is 4. So Q, which was this, is divisible by 4 odd factors. And if you're wondering which those 4 factors are, these are the 4 factors. Now, most of you, I think, missed the case 1 when you were saying 3. And those who are saying 2 only considered 3 and 5. Okay. So I hope, guys, this is perfectly clear. So what is the process of finding odd factors? Or numbers which divide odd numbers that divide the number? You simply discard, eliminate the 2 or the even number, that prime number, if there is any, and you just focus on the odd one and use the same formula to find the total factors. Okay, so I hope this part is perfectly clear. Okay, now let's take the second of the first case which I wrote. Now p is equal to 2 square. So how many odd factors is this divisible by? How many odd factors is this divisible by? And be careful, think carefully and then answer, okay? Think really carefully and then answer. I know the first answer that might come in your mind is, okay, Joe says 1, Kayur says 1, Karishma says 1. Shrishti, I know the first thing that comes in my mind is 0, right? Because you might be thinking, I need to discard 2 to the power 2. That's correct. You need to discard 2 to the power 2. But there's one number which creates all the problem, which is the number 1. This number is still there. Okay, so when I say discard 2, the way I was discarding it, you'll be left with something. So in this case, I need to think in this way. Okay, so I'll be discarding this, and I'll say P will be divisible by just one odd factor, which is 1. As a process, remember this, guys. If n is a number, n is always divisible by 1 and n, come what may. It has other factors. If it has other factors in between, then it's a composite number. If it does not have any other factors in between, then it's a prime number. So 1 and n will always be there. So if I'm taking p is equal to 2 square, and I have scribbled a lot, so let me rub a few things. If I have p is equal to 2 square, if I'm looking for odd factors, I can definitely say that the only odd factor is going to be 1. That's a very important inference. Okay, so I hope now you understand the concept of odd factors. You discard the even number and then work with the remaining stuff. If you have nothing else after discarding it, you'll just say it has one odd factor. That's all. Okay. Now you might ask, you might think, what is the use of this statement? Can anyone now tell me what's the use of this statement? Did anyone was able to figure out what could be the use of this? Where's my pen? Yeah, got it. Now see, the second statement is the same. They're talking about 4y, 4 times something. And they're talking about y. Okay, I don't know what y is. But what they're basically saying is that y, the number of odd integers that divides y, is the word divisible, so I'm talking about factors. The number of odd factors that divide y and that divide 4y is the same. Okay, no, Neeraj, it doesn't say y is odd. Please read carefully. 4y is divisible by as many odd factors as y. So they're basically saying the number of odd factors that divide y and that divide 4y is the same. Is this part clear or not? Because if this is not, there's no use going forward, guys. So kindly mark yes if this is perfectly clear. I'm going to add a yes no poll. Is this part clear? Divisible by as many odd divisors. So they're trying to say the number of integers, odd integers that divide 4y and that divide y is the same. Kindly read it carefully. Don't just look at keywords and then okay, I can see a lot of you have not understood this. So what are you not understanding, guys? Please tell me. I can see 38% of you are saying no. Which again, the question is not complete, guys. Please keep in mind, I haven't finished my question. I will still be solving it. I'm just talking about the statement. Break it down. Break it down and think in this way. You have 4y. Let's take it this way. You have 4y and you have y. They're saying 4y is divisible. So I'm looking at divisible by as many positive integers, as many, when they're saying the number of positive odd integers, the number of odd integers that divide 4y and the number of positive odd integers is the same. As many as means the same, as many as. means the same. So I hope this is clear now. The yes and no poll is still open. If you have understood this, kindly change your response. Say yes if it is clear. Now, what is the use of this statement? Let me tell you guys. See, I don't know what y is, but let me ask you a very important question. A very important question. While finding out the odd integers, does the even number play any role? Now that we have discussed about odd factors, while finding out odd integers, that is divisible, 4y is divisible by as many odd integers as y. Okay, so the number of odd integers is the same. When finding out the odd factors, does the even part play any role? The even part does not play any role. Okay, doesn't it say that if y is 5, then 4y is divisible by? No. What Soumya, what you're saying is wrong. What this basically means is that if 4y is, say, for example, divisible by 5 odd integers, then y is also divisible by 5 odd integers. This is the meaning of the question. 4y is divisible by as many. So the number of odd factors as y. So if 4y is divisible by 5 odd factors, then y is also divisible by 5 odd factors. So I hope this is perfectly clear. Yes, as many integers means they are talking about the number of integers. As many integers as y. So the number of integers. So the number of integers, odd integers as y. But when you're reading as many as integers as y, you're forgetting about the word divisible, Parikshit. Soumya, you're forgetting about the word divisible. 4y is divisible by those many numbers, those many odd factors. So 4y is divisible by, say, 5 odd factors, then y will also be divisible by 5 odd factors. Or you can look at it the other way. If y is divisible by 5 odd factors, then 4y is also divisible by as many factors. So 5 factors as y. 5 integers or factors, what way you want to say it. Is this part clear? Because if this is not clear, I can still see people saying that it's not clear. So Akash, 3 times more factors. I'm not sure what you mean by this. So as I was saying, understand this. If this part is clear, that the number of odd factors for both of them need to be the same. Okay, the number of odd factors by which 4y and y is divisible needs to be the same. Now tell me, is the 4y playing any role while finding out the number of odd integers? Yes, no. Is the number of, let me reset it and ask you again. If I multiply a number by 4, will it change the number of odd factors? That's my question. If I multiply a number of 4, will it change my number of odd factors? Let's focus on the word odd. Number of odd factors. Will it change that? Remember this example. I'll give you an example so that it will be clear. If I have this, okay, and if I have this, and let me remove this for a moment. Let's one sec, guys. If you have these two numbers, will the number of odd factors change? If you have this and if you have this, are the number of odd factors of these two numbers different? Number of odd factors. No, right? I can see all of you are saying no. So look at this. This is one case. I wrote this down deliberately to tell you this is one possibility. When y is odd and when I multiply by 2 square, the number of odd factors is still not changing. But y is odd. Okay. But there could be a case like this also, right, guys? Let me just write it very quickly. There could be a case like this also where y may be even. Let's say y is 2. 4y is this. Now tell me, does the number of odd factors that divide y and 4y, does this change for this and this? Does it change? Yes, no. I know my pen eraser is not working, unfortunately. I have to constantly switch on it. Yes, so you can understand it's not changing. For this also, the number of odd factors is 1. For this also, the number of odd factors is 1, right? In this case, the number of odd factors would be 4. In this case, the number of odd factors is going to be 4. So the number of odd factors is not changing. And notice in statement 2 also, I cannot be sure whether y is odd or whether y is even. Now in this case, y is odd. In this case, y is even. So there are two possibilities once again. I cannot be sure which one is it. So even statement 2 is not sufficient because multiplying by 4 is not changing anything irrespective of the fact whether y is even or odd. Okay, so Gandha is asking, does it not matter that the number of factors are the same, but the factors themselves could be different? Yeah, the fact that's quite possible because I'm looking for, please understand, Sugandha, I'm looking for odd factors. I'm not looking for total factors. The number of factors could, the factors themselves could be different as long as the number of factors is the same. That's fine. That's correct. Yes, I guess people are now getting restless. Yes, the answer is C actually, is E. Sorry, the answer is E in this case. Because see, from statement 1 also, I could not figure out whether y is even or odd. From statement 2 also, I could not figure out whether y is even or odd. Okay. Now, even if I combine them, even if I combine both these statements, okay, I'll still have two cases. I'll still be left with two different cases. One case could be where y is 2. Okay. The other case could be y is 1, something like this. Okay. I don't know which one it is. Even if I combine them, I'll still have two different cases. So I won't be able to figure out whether y is an even number or whether y is an odd number. Thus, the answer is this case is going to be option E. Yeah, so again, that's statement 2 is insufficient. I never said that it's sufficient. Statement 2 is insufficient. Combining also, it's insufficient. Guys, this is a difficult question. I agree that you might still have some doubts. Please post them in the poll in the chat box. I will try to answer them one by one. But at a high level, is this clear? So the main takeaways which I want you to take from this question is, I'll be very fast so that I can go on to the next one. Number one, keep in mind that you do your pre-analysis, figure out which variable you're looking at. Number two, when you're finding the odd factors, the even number does not play any role at all. So even if you have y and if you multiply it by 8, 16, 128, doesn't matter. The number of odd factors is still going to remain the same. And the number could be even, could be odd. Y is an odd number, Atul. So y is an odd number. So y is just one factor, 1. So y could be odd, y could be 2, it could still be even. In both these cases, the number of odd factors is still going to remain the same. Sarah, the reason we are doing this question is so that you understand this now and you take less time in future. Obviously, when you're doing it for the first time, it will take you time. But that's why I'm telling you the process. What is the process? Remember the process. Odd integers can be found by eliminating the even part of it. So eliminate 4, eliminate everything. Okay. And then look at just the part that is there to solve the question. Okay. Okay, I can see two more questions. I'll take these two only very quickly. Yogi says if y is 2, then odd factors will be 1, which does not satisfy the second statement. What is the second statement saying, Yogi? Yogi, the second statement is saying they're talking about the odd factors. If y is 2, the odd factor will be 1, right? You agree with that. Now take 4y. 4y is what? 8, which is 2 cube. Now for that also, the number of odd factors is still going to be 1. 8 has only one odd factor, which is 1. So it is satisfying the second statement also. I hope it's clear. Y obviously could be odd as I've shown here. This part that I've shown here, Y definitely could be odd. This part is basically saying that Y could be even also. I hope, Yogi, that's perfectly clear. Sugandha, what I'm asking, okay, let me read what Sugandha is saying. What I'm asking is that, what do you mean by how? Can you please elaborate? What do you mean by how? Yogi, can you tell me what do you mean by how? So Ganda is asking, what I'm asking is that the statement says the number of odd factors is the same, but the factors can be different. So is that the thought alone sufficient to discard the statement? No, understand that thought is not enough, because what I'm looking here, Sugandha, is whether y is even or whether y is odd. I don't care whether the factors are different or whether the factors are same. What I'm trying to do here is, let me split it down. I'm trying to find out numbers which could be even, which could be odd. Number one, that's very clear. And while I'm looking for even and odd numbers, what I'm trying to see is whether statement 2 satisfies it or not. I don't care whether they have the total number of factors or the factors of those numbers are different. Okay, I don't care about that. Okay, Yogi, you're still okay. Let's do this, guys. Let's move on to the next question because I can see most of you have understood this. Those of you who still have questions, I'll try to type down my response in the chat box. But let's move to the sixth one, guys. Okay. Yogi, I'll answer your question on the chat box only. Here's the sixth question, guys. Let's apologies for taking this long. Let's move on to the sixth one. Yogi, I'm replying to you on the chat box. So guys, when they say how many positive factors, keep in mind we always talk about distinct factors, okay? Even if it is not mentioned, it's implicit that we are talking about distinct factors. For this question number 6, how many positive factors does n have? We're talking about distinct factors. Okay, I can see a few responses. Guys, another 1 minute I'll give it to you because this is also slightly difficult. So you have 1 more minute. So guys, these are questions which you need to get good at to get a Q49, Q50. Okay, you need to be comfortable with working with variables, number one, and you need to be comfortable with using the formula also, even when you're given it indirectly. Okay, another 30 seconds, then I'll end the poll. Ten seconds, guys. Okay, I'm ending the poll. And guys, I have a very interesting response here. I can see about 57% of you think the answer is D. How many of you found this question, I would say, how many of you found this difficult? How many of you found this question difficult? Did you have a hard time inferring these statements, each and every statement? Okay. Okay, guys. Okay, fine. Difficult statement one. Okay, so guys, the reason behind giving this question is because, see, when I tell you, when I give you statements like these, like, tell me what is the total number of factors of this. All of you are very quick with this, right? You know the total number of factors is this, right? You do it very quickly. But GMAT knows that you will be able to do it. And they still want to test you on total factors, right? So what they're going to do is they're going to ask you the question the other way around. Okay, what they're going to do is they're going to give you the total number of factors. So some statement would have total number of factors is, say, for example, 6 or something like this. Okay, and then they might ask you to figure out either the value of n or how many positive factors does n have, those kind of questions. So you should be comfortable from moving either from the numbers to the total factors or from total factors to the numbers. You should be comfortable with this. If you're not, 700 level questions would be slightly difficult. Okay, now the statement in this question does not have, we cannot do much in it. N is a positive integer. Okay, that's good. So I know n is greater than 0. That's fine. And I need to find out how many positive factors does n have. So you should be able to infer that you're looking for the total factors of n. That's what you're looking at. Okay. Now, there's nothing else since we can do, so we'll move on to statement 1, which is n cube has exactly 6 positive factors greater than 1. So can anyone tell me, what does this mean? Can anyone tell me what is the total factors of n cube? What is the total number of factors of n cube? What are the total number of factors of n cube? Anybody? Okay, Akash says 7. Okay, good. What about 7? Good. So everyone guys understand that it's 7, right? That's pretty good. Now we know that the total factors formula is a plus 1 times b plus 1 times c plus 1, blah, 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 depending on what n is, right? So if n is p1 to the power a times p2 to the power b, depending on how many prime numbers do we have. I emphasized on this in the starting, at the starting of the session, right? So now when I know that n cube has total factors as 7, what I can do is I can write down a plus 1 times b plus 1 times c plus 1, blah, 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 is equal to 7, right? Because that's the formula for total factors. Now, can you tell me what is the value of a? So Joe, that's what I was talking about. When I told a plus 1, b plus 1, I was using this formula to solve this question. I was writing n in terms of prime numbers, and I was taking the powers and adding 1 to it to get the total factors. Okay. Now, when you have n cube is equal to total factors as 7, and I know the total formula is this, can you tell me what will be the value of a in this case, b, c? What will be the value of these? Anyone? See, understand the left-hand side is an integer. The right-hand side is also an integer. Okay, Akash, that's good. So you were able to do it directly. That's absolutely good. But for those of you who want to understand what you're doing here is, you're writing it like this. Think in this way. A plus 1, b plus 1, and 7 is basically 7 times 1 times 1 only, right? You cannot do anything. You cannot split it further. Okay. So when you compare these, when you compare the left-hand side, right-hand side, when you're comparing these two, notice I can say a plus 1 is equal to 7. So a is equal to 6. Okay. And the remaining would be 0, right? B has to be 0, C has to be 0. Then only 0 plus 1 would give you 1. 0 plus 1 would give you 1. That's the way we write it. The other way is, if you don't want to get confused like this, what you can do is you can look at the number and see whether you can split it or not. If you cannot split it, like 7 is a prime number, all you can write it is as 7 times 1, nothing else. If there's no further way to break it down, prime factorize, you simply take one of the variables. You just take one of them because the rest of them have to be 0. So you can take this, you can say a is equal to 6. So what is your number? Your number is n cube. N cube has 7 factors. So you can say n cube is nothing but p1 to the power 6. So that when I find out the total factors of this, I would get it as 7. I hope this part is clear. Now, if n cube is p1 to the power 6, you can say that n1 has to be n has to be p1 square, right? You can divide by 3, the powers by 3 both sides. So the total number of factors in this case, you take the power, so the total factor of this would be 2 plus 1 equal to 3. Please tell me if there's any doubts out here. Any doubts at all? So I'll tell you the process. The process is, when you find out the total factors, and I'm simplifying it for you so that it doesn't get complicated, you take it as 7, okay? If you cannot split it, just one prime number, you just take one of the numbers, a plus 1, and you equate it to 7. And you find out the power. So you can say p1 to the power 6 as I wrote it here. Okay, you're looking for n. So obviously you need to break it down into n. Once you find out n, you can again use the total factors formula to find out the total number of factors. Okay. So obviously statement 1 is sufficient. If statement 1 is sufficient, your answer has to be either A or D. So those of you who marked the answer as B, C, E, I hope it's clear, especially 19% of you marked the answer as just B. I hope it's clear why statement 1 is sufficient. Okay. Now let's come to statement 2, which is, I would say, a slightly trickier statement. Now statement 2 is saying 3n, statement 2, 3 times n has exactly 3 positive factors greater than 1. So how many factors does it have? Can anyone tell me? If you have understood statement 1, you should be able to tell me how many total factors does it have. How many total factors, guys? Mohit says 4, right? So 3 plus 1, 4. Likit also says 4. Very good. So you've understood. They have 4 factors. Now see, let's talk about 4. This is where things get interesting, and this is where you might make a mistake. Okay, you're saying 4. Very good. That's correct. Now 4, notice, can be splitted into 2 times 2. So if the number that is given can be split into 2 parts, okay, there can be 2 possibilities. One is when you're using the formula a plus 1, b plus 1, c plus 1, you can say 4 is equal to a plus 1 because 4 is just one single number, and you can say a is equal to 3. Okay, so in this case, you would say the number n, you had 3n, right? You had 3n. So you can say 3n is equal to p1 to the power 3. Now tell me, if 3n is p1 to the power 3 and this is 3 to the power 1, what is n in this case? Can anyone tell me what is n in this case? What is the value of n in this case? p1 is a prime number. Left hand side you have 3 to the power 1. So obviously n needs to be what? What will be the value of n? We can find out the actual value, Adela. We can tell what is the actual value. I can see that most of you, Rudra says the correct. Yes, guys, understand you. There is no other prime number on the right hand side, and there's one prime number already on the left hand side. So if there's no other prime number on the right hand side except for P1, and there's one prime number already here, that means n has to be also the same prime number. So you can say it's like this. So basically what you're getting here is that n is equal to 3 square. I hope this part is clear, guys. That's case number 1. Now, those of you who did mark the answer as D or A, you did not consider these cases. What you did was you just took one of these cases, that's all. The other case is, as I told you, if you can split it, split it. If you split it, you take 2 of them. And you will say A would be 1 and B would be 1. So you can say 3 to the power 1 times n is equal to p1 to the power 1 times p2 to the power 1. Now p1 to the power 1 is already 3 to the power 1. So n could be p2 to the power 1. So in this case, n is equal to p2 to the power 1. And in this case, the total factor is going to be 2. So notice you're getting 2 different answers. In this case, you are getting n is equal to 3 square. In this case, you're getting n is equal to some prime number to the power 1. Since you're getting 2 different answers in this case of the total factors, that is why you'll say this statement is not sufficient. So the answer in this case will be option A, which I think about 8% of you marked it. Now tell me, guys, is this clear? Do you need more explanation on this? This is the kind of question where you need to learn to split it. I know this is something new, so it might be a little overwhelming. But these are questions which will help you get to 4950 if you're able to solve these easily. I'll reiterate the process very quickly in 1 minute. First step is once you find out the total factors, you use the formula, this one, okay? If this cannot be broken down, you just take one of them and equate it as I did it here, okay? If the number that is given to you, like in this case, I was given 4. Now 4 can be broken down, like it can be written as 4 itself, and it can be broken down also. So you need to consider both these cases. Once you're considering as a single number, just take one of them, a plus 1. If there are two, if you can split it, then take two of them and find out the variables, what it can be, and then infer the value of n. Okay, Yogi says, can you explain statement 2? Please explain statement 2. So you see, guys, I would ask you to tell me exactly what you did not understand. If you tell me to explain statement 2, the whole thing, then it would take another 5 minutes. So if there's a particular part which is not clear, please tell me that. I'll be more than happy to explain. Which part is not clear? Statement 1, it seems, is clear to everyone. So please tell me which part is not clear. I'll use this part of the board to explain it to you very quickly. Tell me which part is not clear. Did you understand that 4 can be broken down into 2 parts? Think in this way, guys. I'll explain it one last time very quickly. N is this, right? Now 4, if it's written as only one part like this, and I'm talking generally, okay? I'm not talking with respect to the question. First of all, I'm just talking generally, okay? You would say A is equal to 3, and N would be simply P1 to the power 3, that's all. And this is a generic thing that I'm talking about. If it can be broken down into 2 parts, you write it, you take 2 of them, okay? And then compare. If A plus 1 is 2, then A has to be 1. If B plus 1 is 2, then B has to be 1. So from this case, you can say N is equal to P1 to the power 1 times P2 to the power 1. That is what you can write in general. Now in this question, your capital N is basically 3 times small n. So in this case, you would say 3 to the power 1 times n is equal to P1 cube. P1 is a prime number. I'm emphasizing on it again, prime number. So if the right-hand side has just one prime number, the left-hand side should also have one prime number. The power is 3. You already have a 1 power here. So from where will you get the remaining power? You'll get the remaining power from here, from n. So you would say n is 3 square, okay, is equal to P1 cube. I hope this is clear. This is one case. When n is 3 square, the total factor of n is going to be 2 plus 1 equal to 3. In the second case, your n is 3 times n, 3 to the power 1 times n. And all you need to do is compare, guys. Compare it. Compare this with this, compare this with this. So notice in this case, you're getting another answer. You're getting n is equal to P2 to the power 1. And that would be going to be, the total factor is going to be just 1 plus 1. So here you're getting the answer as 3. Here you're getting the answer as here you're getting answer as 3. Here you're getting answer as 2. You're getting two contradictory answers. That is why this is not sufficient. Neeraj saying, sir, even GMAT video course drills are as you are explained. Yes, Neeraj, in the GMAT quiz course also, this is the way I have explained. I hope you're liking it. I don't know whether this is clear or not, but this is the way I explain my booster files also. So Yogi, Akash, Akash, is this part clear why you're getting two answers now? Because if this is clear, I would like to do one more question. We are already running late. So I would like to do one more question with you. If this is clear, Akash, can you see you're getting two different answers? You're getting one of the answers as 2, one of the answers as 3. I hope this is clear now. Yogi is saying, but 3 has only 2 factors, 1 and 3. We can calculate for n unique values. Yogi, I would say, frankly speaking, I would say that you need to kindly go through the total factors formula a bit once, because you're looking these numbers in isolation. So my suggestion would be kindly go through the video lessons of prime numbers once to understand how am I calculating this. Okay. So guys, if this is clear, I'm going to solve one more question. And in the interest of time, let me just skip a few slides and give you one of the questions which I would want to discuss. Just one sec. Let me take a call. Which I should. Okay, let's do this one, guys. Let's do this one. Question number 9. Those of you who are facing problem, I would strongly suggest you're facing problem because the concept of primes in LCM GCD is not perfectly for you, clear for you, which is totally okay, guys. But I would want you to go through the video lessons once if you're still struggling to understand how to find out the total factors. If you don't understand how to find the total factors, these questions would all be difficult. So this is the last question for the day, guys, and which is testing you on the concept of LCM and GCD, direct application question. Okay, I've started getting a few responses, but they are still quite less. So I'll give you another minute to solve it, guys. Another 30 seconds. Okay, I'm going to end the poll in 10 seconds, guys. So those of you who haven't responded, please do so very quickly. Okay, so let me end the poll. Okay, as you can see, guys, this is again all over the place. 35, 30, 20%, 10%, 5%. This is, I would say, a kind of question which I was talking about in the starting, where you know how to find out the LCM GCD directly. Okay, if I give you two numbers and I tell you to find out the LCM GCD, you will be able to do it. But this is a kind of question where I will be serving you, or GMAT will be giving you the LCM GCD, and then they're going to ask you, tell me what is the value of P, or what is the value of Q, or P plus Q, and so on and so forth, right? But please understand, the process does not change a lot. Okay, the only thing in 700 level question, if you would have noticed, is that the inferential skill, a lot of inferential skill is needed to decide what to do next. In this question also, the first thing that you should do when you're solving it is prime factorize. Okay, because that's the first step that's always going to be. So if you see that the LCM of P and Q is 630, you should prime factorize and write it as, can anyone tell me what will I get here? I'll get 2 to the power 1, 5 to the power 1, 3 square, 7 to the power 1. Okay, so I hope everyone got this, right? Same way, I'll work with the GCD. The GCD of two numbers is going to be, it's given as 18. So what I'm going to do is I'm going to first of all split it only, make sure that I do that job then and there. Okay, so this is done. Now, forget the question for a moment, okay? Forget about these statements, everything at all. And tell me, if I ask you to find out the possible values of P and Q, will you be able to do that? Will you be able to figure out what could be the possible value of P and Q? Anyone? For example, if I tell you, tell me one value of P and Q which satisfies this, a value of P and Q which is valid for both of them. Can anyone do that? Okay, Neeraj is saying yes, but I want you to show it to me, guys. Give me one value of P and Q. Okay, Sarah says no, that's fine. I'm going to teach you, don't worry. But can anyone show me? We can do hit and try. Okay, good. PA times Q is LCM GCD, but time consuming. Okay, see, what you can do is you can make certain small inferences that can help you get the answer. I won't say very quickly, but if you go methodically, it would take you about 30 seconds to come up with some cases. And let me show you how. The first thing that you should do whenever you have a scenario like this, you plug in the GCD then and there only. Like for example, I can see the GCD is 2 to the power 1, 3 square. So I know GCD is a common part, right? Which is present in both the numbers. So what I'm going to do is I'm going to say 2 to the power 1 times 3 square has to be present in both of them, come what may. Okay, because it's a GCD, common divisor. It's present in both the numbers if you remember the process of GCD, right? Is this part clear? Because I'll move on after this only. Okay, Arun, Yogi, yeah, you all are correct. That's good. Atul, you're also correct, right? So I hope this part is clear because if the GCD is 18, that means 18 is present in both of them. Then only because the factor means it will divide both of them. That means 18 has to be present in both of them. So notice I'm taking care of this. This part is done. I don't need to worry about it at all. Now, what is the LCM? What did I tell you about LCM? LCM, when I'm finding out the LCM, I'm taking all the prime numbers that are there and I'm taking their powers. And this 5 to the power 1, 7 to the power 1 could be present anywhere, right? But it has to be in either of these two numbers or both the numbers, whatever be the case. So let me write on a few cases and you tell me which ones are valid and which ones are not, okay? Let's say I'm writing one case like this. I'm writing another case like this. And let me name them. Let me call this as A, B, and C. Tell me out of these, which ones are valid and which ones are not. Out of these A, B, C, these three cases which I have written, out of these three cases, are all three valid? None of them are valid. One of them is valid. Which one is valid? You need to tell me. So you can write it like this in your chat box. For example, A, B, C all valid, or A, B, C none valid. When I say valid, what I mean is it satisfies all the condition that is given. Okay, Yogi says A and B. Soumya says C is not valid. Sarah says A and B. So that's absolutely good, guys. I'm really happy that you are able to understand this. See, how did I make that inference? After doing this, after putting this 3 to the 2 to the power 1, 3 square, I made another inference. What inference did I make? The inference that I made was that these numbers cannot be present in both of them. So what I mean by that is I cannot have 5 to the power 1 present in both of them. So what does that mean? It means that either I need to split this into P and Q, okay? Either need to give it to either P or Q, or I need to give this whole thing to one of the numbers. Okay, so which basically tells me that cases like C is going to be invalid, so I can remove them. That's not possible. Also, I wrote P and Q, I know, but I don't know which one is P, which one is Q, frankly speaking. So I can say these are my two cases. These are my two cases. One case could be where both 5 to the power 7 to the power 1 is present to one of the numbers, which number I don't know. Or or the second case could be 5 to the power 1 is present in one number, 7 to the power 1 is present in another number. If you are able to do this inference before going to the statement at a high level, I'm not saying write down all the cases. Okay, and in GMAT, believe me, when they give you questions like these, they are not going to give you complicated expressions. They're going to give you something like this, where the number of cases would be limited to either 2 or 3 only, not more than that. Okay, so it's better to do it this way. Make these cases. Now, once I've done making these cases, I can go to these statements. First statement is that P is a multiple of 35. Now, if P is a multiple of 35, which case can I discard out of A and B directly without even thinking twice? Which case? P has to be a multiple of 35. So which case is not valid in this case? There are only two possible cases. Which one is not valid? Yes, Armin, I'm recording this webinar. B is not valid, right? Because out of these cases, none of them is a multiple of 35. So this has to be the only case possible. And they're telling me which variable is a multiple of 35. So I can say this is P, this is Q, and I can find out P minus Q easily. See, it did not take me much time to work with these statements because I did my inference beforehand. And it helps, guys, believe me. Okay, so statement 1 is sufficient. So the answer cannot be B, C, and B, C, and E, really, sorry. D is still there. B, C, or E cannot be my answer. So answer has to be either A or D. So those of you who marked B, C, or E, I hope it's clear where you faltered. I can see a lot of people marking the answer as C. Those who are marking the answer as C, I'll tell you the reason behind that, because it's a basically C and E trap that is set here. Okay. Those who are marking E, the conceptual knowledge is still not really clear, guys. Those who are marking C, your conceptual knowledge at a certain level is clear, frankly speaking, but the analysis part is not still really strong, where you need to improve your analysis. Inferential skill is what I would call it. Okay. So statement 1 sufficient. Let me go to statement 2. And when I'm going to statement 2, I'm going to have to remove this. I don't want to be biased with statement 1. So now I'll look at the second statement. They're saying that the GCD of Q and 35 is 1. Okay. Now, I don't know what Q is. What I will do is I'll look at both the cases and see in which case the GCD of Q and 35 can be 1. Okay. So let's take the first case. Let's take this case. Okay. Let's take this case. Now, in this case, if I obviously Q cannot be this. Q cannot be Q cannot be this. If I make this as Q, then the GCD of Q and 35 won't be 1. It will become 35 only, right? So if I look at case A, I can say Q cannot be this number, because if it is this number, the GCD won't be 1. So I know this has to be P and this has to be Q. At least for case A, this has to be P, this has to be Q, because if Q is this, then the GCD is definitely 1. So rest assured. Now I'll go to case B. I will not discard it. I will not say, hey, it's done. I'll look at B and make sure there's no other case possible. Okay. Now let's say if this is Q. If this turns out to be Q, then the GCD of Q and 35, and keep in mind 35 is 5 to the power 1 times 7 to the power 1. If I take this and this, then the GCD of these two numbers is going to be 5 to the power 1, because 5 to the power 1 is common in both of them. But I need 1. So Q cannot be this. Let's take this as Q. Even this is not possible. Why? Because the GCD of this and this would be 7 to the power 1. But I need 1. So I can discard this case totally. I can say, hey, this case is not possible, because because if I take this as Q or take this as Q, the GCD is not 1, but I want the GCD to be 1. And the only case where it is possible is this case only, when P is this, Q is this. So even this statement is sufficient, and the correct answer in this case is going to be option D, which only 30% of you could mark it. So the reason behind giving this question is, guys, to teach you this methodology of finding out, writing down the cases a bit. It may seem lengthy, but if you do it methodically, make two inferences. Like first inference I was made was 18 has to be there. Second inference which I made was 5 to the power 1, 7 to the power 1 cannot be present in both of them. It has to be either splitted like this, or I have to give whole to one number. If you make certain inferences like this, you'll always get the question correct. Okay. So guys, I hope this discussion helped you. I would obviously would want some feedback from your side. So please let me know. I'm sharing one more thing. Just one sec. Give me one sec. So let me give you my feedback first, and in the meantime, you can also add your feedback. First thing is that whenever you're coming to a session, it would be great that if you can go through the basics of this session. When I say basics, just look at what are factors, what are divisors, so that the session becomes more fruitful and we can discuss more difficult questions. Shushri, tell me what was the answer. You have to tell me. If this was clear, you should be able to tell me what will be the answer. In fact, I've marked the answer in the slide. Okay, so as I was saying, guys, make sure that you go through the basics a bit. If you do that, then that way the sessions can be more fruitful for everybody. Whatever I've explained is all this here. All these explanations are there in the video course also. Yes, Shrushti, the answer is D, correct. So all these things I've explained in my video lessons also on GMAT Wiz. So if you go there, if you look at LCM GCD, if you look at primes, if you look at divisibility, I have discussed all these kind of questions, the methodology, and there obviously I've discussed in more details. As I told you, this was 1.5 to 2 hour session, so it will take some time. But if you want more elaborate explanations on this, I would strongly suggest to look at our video lessons to get this to learn more about it. Now, as Piyush was saying, I wanted to give you questions on this also, right? So if you have understood this webinar properly, and if you want to test yourself, how much have you understood? I know we did not discuss all 11 questions, but if you want to test yourself, and if you are a student, so a paid members, then what you can do is you can go to your course, go to your final frontier, and there you'll see an option of live session, a block called live session quizzes. So there I have created a quiz which tests you exactly what I have discussed in the live session. Okay, so make a note of it, guys who are our students. Go to Final Frontier, and in Final Frontier, you'll find us a block called Live Sessions. Now, those of you who are not our student, guys, even you can take access to these quizzes. What you need to do is go to your free trial section, and in that you'll see at the bottom section you'll see a live session quizzes. Okay. Uh, but keep in mind, for free trial people, the access is for a limited number of days. Okay, the quiz is not going to be forever. It's just going to be for 5 days. So, for example, if you this quiz is basically will be there till Friday. If you want to take the quiz, you can take that quiz till Friday. When I say Friday, I mean 26th. Okay, till 26th of June, you will have access to this quiz. And when I say paid students, that means all paid students, be it verbal, be it quant, be it GMAT prep, whatever. If you are a student, all you need to do is go to your final frontier and you will find it and you will have access to it for students. Those of you who are free trial members, you have to go here and take the quiz. It's for free trial users, the access is limited for only 5 days. After that, you won't have access to this quiz. Okay. I've also added a poll. I would love to know whether you like this session or not. So Vedanshi, I hope that answers your question. Neeraj, if you have doubts, are there any live sessions too? Neeraj, doubts are cleared for our paid students, but for free trial users, unfortunately, we do not have any live sessions to clear doubt at this point of time. And for paid users, obviously, the doubts are cleared on our forums only. We are not taking any sessions as such, where it would basically there's no open forum as such. Okay. Basically, Neeraj, you need to look at your weighted score. So when you're taking the quiz, guys, if you have understood this, Neeraj, no, unfortunately for paid, that's what I said. That's why I said both these things. For paid also, we do not have any live open sessions at this point of time. Okay. In this quiz, I would suggest guys try and target at least 60% plus. If you're getting 16% plus in these quizzes, then that means you have understood the quiz. If you're getting anything less than 60%, then that means you need to work more on this. You need to do better in these quizzes. You need to go through your video lessons once more for prime numbers, divisibility, and LCM GCD. It's really important, especially those of you who are targeting maybe Q49, Q50. You need to go through the lessons. Okay. Any other questions, guys? Feel free to ask anything at all. Related to general GMAT prep, related to anything else. The next session, guys, is going to be on the art of taking values, the art of taking X. Basically, I'll talk about I'll take questions where I'll show you how to take which variables to assume, why you should assume variables, and how should you decide if you need to take variables or not. As a prerequisite, I would request all of you to just go through a bit of equations, linear quadratic equations, so that you're comfortable with that. And if possible, do a bit of word problems if you can, because most of the questions that I have are going to be close to word problems only. Okay. Karishma is saying, I missed the session on algebra. Will you upload the video on YouTube? Yes, Karishma, it's already uploaded on YouTube. You can see the session on algebra on YouTube. Okay, Shushti says recording of the session. Recording, guys, let me tell you clearly, recording will be shared with you via mail on Monday. Okay, it takes some time for us to convert it, edit a few things, right? So you should be able to have access to that on Monday. Okay, those of you, again, I'll say that you had a problem with this while during this session, I would strongly suggest go through the basics first a bit before coming to the session, so that you can maximize the benefit out of this. Okay. Yeah, Mohit, I would love to discuss more questions, but you need to understand I need to care everybody when there's a classroom session, right? So I don't feel comfortable moving forward if students haven't understood my concept. Uh, uh, so I would like to make sure that they do that. Okay, and a lot of people out here don't have access to any courses, if you can understand. So that way, it's difficult for me to discuss a lot of them. Okay, Shushti is saying, what topic should we come prepared next? Shushti, as I told you, just make sure that you are comfortable with quadratic and linear equations a bit. Okay, you should be able to find out quadratic equations, the roots of the equations. You should be able to solve linear equations properly, and do a bit of percentages. If these three things are fine, we should be okay with it. I will be discussing a few time and distance, time and work question, but for that, you just need to know the formula: distance is equal to speed times work is equal to rate multiplied by time. If you know this formula, you should be okay with it. But the session would be slightly focused on word problems, because that is where you need to take variables a lot. So I would be focusing and telling you how to work with those. Okay, so the idea is to tell you when to take variables. People are not sure when to take variables. I'm going to discuss that. Okay, so that's all I need you to prepare for the next session on Sunday. Okay, guys, I'm going to end the poll now. If there are no more questions, I don't see any more questions. I think I've answered all of them. Yep, I think I've answered all of them. Do we need to ever use the quadratic roots formula in actual GMAT exam? No, Mohit, I would say, if you face a problem in finding out the factors, in splitting it, then you may want to use it. But so far, I have rarely come across a question where I have to use the actual quadratic roots formula. So when I said you need to know quadratic equations, what I meant is you need to know middle term factor. You should be able to break it down and write it as x minus a times x minus b. As long as you're able to do this, I am happy. Glad to see that all of you like this session. There's a lot more to come in the future sessions. Please do attend it. I'm sure you're going to benefit from it. And once again, if you have any questions, guys, related to this webinar or anything, please feel free to write to us. Okay, we will try to answer as many questions as possible related to this session or in general also. Okay, with this, guys, I'm going to end the session. All the best, and once again, feel free to get in touch with us if you need any help.